Okay, let's get started. Good afternoon, everyone. Welcome to today's webinar. My name is Yichao Rui. I'm a scientist at Rhoda Institute, where I serve as a research director of our 41 years old farming system trial. And today's webinar will be hosted by myself and my colleague, Annie Benson. Annie, do you want to introduce yourself briefly?
Sure. Yeah, I'm Annie Benson. I'm a research technician here, also on the farming systems trial and of some of our other agronomy-based trials.
Okay, great. So today we will be talking about reducing tillage to improve soil health and organic grain production. First of all, some housekeeping rules. During the webinar, we cannot hear you, but we hope that you can hear us clearly. And if you have any questions during the webinar, please use Q&A function to send them through, and we will respond to your question at the end of the presentation. And if you experience any difficulties, please call Justin Barkley, our education manager, on this number here on the screen. And as usual, this webinar will be recorded and posted onto our website and be shared on our social media. So you can go back and watch them later. So in today's webinar, I will first talk a little bit about the history and the current status of organic no-till agriculture systems in the United States. And then Annie will introduce some of our research projects on organic and no-till, in which we compare different organic and no-till options. And together, we will share with you some of our latest research findings that we found in the last 3 years of the project. And first of all, I'm sure that many of you in this webinar know Rhoda Institute already, but for those who are not so familiar with Rhoda Institute, we are a nonprofit research organization founded by Yichao Rui, our founder in 1947. And our headquarters is located in Kutztown, Pennsylvania, about an hour from Philadelphia and 2 hours from New York City. But we also have several regional resource centers across the country and in Italy. And here we believe that healthy soil equals healthy food and equals healthy people. And we also believe that agricultural systems should be more regenerative. So agriculture should be not just sustain resources, but also can improve resources so as to build a strong foundation for long-term food production. So I'm sure that some of the principles of regenerative organic agriculture are well known already. For example, eliminating chemicals, diversifying crop rotations, maximizing living cover through cover crops and perennials, and using natural fertilizers instead of chemical fertilizers, and reducing tillage and soil disturbance. So many organic farmers are doing great already in the first 4 items, first 4 principles, but reducing tillage is still a big challenge for many organic farmers because tillage has been around in organic agriculture systems and still a big part of organic agricultural management systems. So we know that for as long as humans have been exercising agriculture, tillage has always been a part of agriculture. We sometimes need to prepare the soil, prepare the seed bed to make sure that the soil and field conditions are favorable for seed germination. So we need to prepare the seed bed by tillage. Sometimes we need to cultivate to control the weeds, to get rid of the weeds that will compete resources such as water, nutrient, and sunlight with our crops, right? So this is especially true for organic systems because in organic systems, farmers do not spray herbicide to get rid of weeds. So organic farmers usually rely on cultivation to control and manage the weeds. But in recent decades, we have learned that too much tillage or frequent tillage can cause some problems, especially can cause soil erosion and runoff, right? Especially if you are in Pennsylvania, where a lot of fields are on a slope. And if you happen to till your soil and there's a big storm, you can imagine how much soil will be lost on your field, from your field, right? So frequent tillage can degrade our soil quality, soil health. So that has attracted a lot of attention recently. There's a consensus that we need to reduce tillage intensity and frequency in our organic agriculture systems. However, reducing tillage in organic agriculture system is challenging, right? And usually it's achieved in different ways compared to conventional agriculture systems. So in conventional agriculture systems, achieving no-till or reduced-till is relatively easy with the development of the genetically modified seeds, for example, the Roundup Ready soybean, Roundup Ready corn, in combination with glyphosate. A lot of farmers have achieved the no-till, right? But in organic systems, farmers do not spray, so they have to use some chemical-free ways to achieve no-till. So at Rhoda Institute, and also together with the efforts of many agricultural researchers and professionals, and the so-called cover crop-based rotational no-till systems have been developed in the last 2 decades. So this kind of organic no-till system features planting an annual cover crop in the fall of the previous year, and the cover crop will grow over winter and cover the soil in the winter time, and into the spring they will grow a lot of biomass. So we can use tools to terminate the cover crops mechanically and plant the cash crops into the residues of the cover crops. In the growing season, the cover crop residues will become a mulch that can suppress weeds, with that eliminating the needs of cultivation, right? In the middle, in the picture in the middle, in the bottom, you can see the red big cylinder that's called the roller crimper. That was designed by Jeff Moyer, our CEO at Rhoda Institute. It's a big cylinder. So now, in the last two decades, or most recently in the last decade, we have done some research comparing organic till and no-till systems and how if it works. For example, in our long-term farming systems trial, which is now 41 years old, started in 1981. Right, with 3 systems: conventional, organic legume, and organic manure systems. We divided these systems into full till, FT, the full tillage till system, and reduced till, or the RT, which is a rotational no-till system in 2008. Well, sorry, in the conventional system, the reduced till is completely continuous no-till. But in organic system, the reduced till is the rotational no-till system. And we found that after about a decade, reduced tillage has shown some benefits in soil health parameters. For example, here you can see the soils we collected from all these 3 systems divided into full tillage and reduced tillage. You can see that reduced tillage tend to improve soil respiration and soil protein, which are the soil health indicators, biological indicator of soil health. So we see there's a benefit by implementing no-till or reduced till into the organic systems, right? So that actually showed that if you are already doing organic, that's great, right? You are planting cover crops, you are not eliminating chemicals, you are doing a lot of crop rotations, that's great. But if you can implement no-till or reduced till into your organic management system, then you can further move towards more regenerative, right? But there are some questions in reality. How can farmers achieve organic no-till in reality? For example, some farmers, they are located in the northern region, or they only have very short window for cover crop planting. And by the time of late spring, the cover crop biomass is less than ideal. So what quantity of cover crop biomass is needed to control weeds, right? And things like, what if I don't have access to a roller crimper? Well, other tools work equally well, right? And also, can no-till actually improve soil health, right? Well, no-till compromise soil nutrient availability, because we know that frequent tillage is bad for soil health, for soil structure. But when you till the soil, you're kind of also incorporating your cover crop residues, you're accelerating the decomposition of organic matter and cover crop residues. So that can actually, help with the short-term nutrient availability that might be needed for your organic crops, right? So while no-till compromise nutrient availability. So these are the questions people may have when they approach organic no-till. So to answer these questions, we started a project together with University of Wisconsin-Madison and Iowa State University with the help of the industrial partners to study the innovation of different cover crop-based organic no-till systems, how they improve soil health, nutrient management. We have, in total, in this big project, we have 3 states, 9 locations, 3 growing seasons from 2019, 2021, and 2 crops, corn and soybean, the 2 largest commodity crops in the United States. So the objectives of this project really is to test the effectiveness of these different various organic no-till system, which Annie is going to introduce in a little bit, in terminating cover crops, controlling weeds, supplying nutrients, and maintaining the yield and of cash crops, and also to determine the impacts of these management systems on soil health. So now I'm going to turn it over to Annie to walk us through some of the detailed project information, including the treatments and some of the major findings in the last 3 years.
All right, thank you, Yichao. So as Yichao mentioned, we conducted this experiment in both corn and soybean systems. However, we have some limited time today, so today we're only going to go over our soybean results. So here at Rhoda, we tend to plant a cereal rye cover crop preceding our soybean cash crop. And we chose cereal rye because it produces a lot of biomass very quickly. And from other on-farm trials and from literature, we know that soybeans tend to be fairly susceptible to weed pressure. So a high biomass producing cover crop really lends itself well to greater weed suppression during the cash crop growing season. All right, so one of the variables we looked at in this trial is rye cover crop planting date. So we planted half of our plots on September 15th and half on October 15th. And the purpose of this was to see if cover crop planting date has a lasting impact on the ultimate cover crop growth and biomass that these plants put on. The other treatment is how we terminated the cover crop. So we compared 3 no-till treatments to each other and also to a tilled control. Our tilled control will be referred to as plow and cultivate throughout this presentation. And our no-till treatments included a Rhoda roller crimper, a Dawn roller, and mow and ted, which is a haybine mower and a tedder. And we'll go into these in a little more detail. So in our plow and cultivate system, it's kind of a typical organic tilled grain system. So we use a moldboard plow, disc, pack, and then come through and plant. And then we continue to cultivate as needed throughout the season until that soybean canopy closes. On the right side of the screen, then, we have our 3 no-till treatments. So the Rhoda roller crimper, as Yichao introduced, was designed here at Rhoda by Jeff Moyer. It's basically a very large, very heavy steel cylinder that can be filled with water for extra weight. It has these chevron-shaped fins or blades on the front that as they roll, they kind of crimp the cover crop every couple of inches. This breaks cells in the stem, in the cover crop stem, to kind of ensure that we're actually killing those crops, that they won't just bounce right back up after we drive off the field. And then the Dawn roller is our next treatment. It's a modified roller. It's manufactured by Dawn Equipment in Illinois. It kind of runs off the same concept as the roller crimper. However, the rollers are split up into segments that are side by side. It's also hydraulically controlled, which allows for more precise changes in things such as downward pressure and seed depth. And that kind of allows us to adapt better to varied conditions, including uneven ground and things like that. And our final treatment was mow and ted. And again, this is a haybine mower and a hay tedder. And so for those of you who aren't familiar, a haybine mower is a type of mower that just cuts stems down at the base and lets them fall to the ground. It doesn't chop up residues into little bits. And so this residue that it's creating will stick around for much longer. It won't degrade right away like some other mowers would. And we come through with a tedder to kind of fluff up the rye cover crop biomass and spread it out as evenly as possible throughout the field. And we included this treatment because haying equipment is something that anyone could have. It's not specialized cover crop termination equipment. So we want to see really how this type of non-specialized equipment stacks up against the specialized equipment that is less accessible in general. All right, so let's look at these. So on the this is a picture kind of from mid-planting in one of our experimental fields one year. So on the left, we have a plowed plot. So at this point, this had, again, been moldboard plowed, disked, packed, and then planted into. We incorporated the cover crop into the soil. So you see it's not on the soil surface, but it has been like plowed in. And then on the right side here, this is a roller crimped plot. And so here you can see it's still green. All the cover crop is still on the surface. We didn't remove any from the field. And so this will stay on the surface throughout the season, throughout the soybean season, and stay on the field as like a thick mulch that will hopefully suppress weeds. All right, so today we're going to introduce some of our research findings from this experiment. And so these will include cover crop biomass, cover crop termination efficacy, weed pressure, yield and profitability, and finally, in-season soil health. All right, so as Yichao mentioned, organic no-till systems really have to rely on cover crops for weed suppression because we don't have chemical sprays as options or like cultivation tools as options to reduce weed pressure. So cover crop biomass is a very important factor in an organic no-till system. So let me orient you to this graph really quickly. So we have our rye biomass split up by year, 2019, 2020, and 2021. And each of those split by our rye planting date. So either planted in September or October in green or blue. There's, in addition, a horizontal line at about 8,000 kilograms per hectare. This is the target biomass. So this is kind of the agreed upon threshold in literature, above which we tend to see fairly successful weed suppression, and below which we see less successful weed suppression. All right, so in this we see that in 2020 and 2021, all of our crops did reach that threshold, but did not reach it in 2019. And interestingly, there was no significant planting date effect on this. So rye that was planted in October produced statistically similar amounts of biomass as rye that was planted in September. So here we see obviously some differences between years. So Yichao and I explored some options, some factors that might have contributed to that. And the factor that seems most likely is just weather variability, so precipitation. On this bottom right graph here with the orange bars, we have total precipitation throughout the rye growing season. So that's September through May of the following year. And the horizontal line is the 40-year average total precipitation value for that time frame. So we see 2019 was a fairly wet year, and 2020 and 2021 were maybe a little dry, but were fairly close to the norm. I think just the wetness of 2019 really did not give great conditions for a healthy stand of rye. So interannual weather variability really does have potential to affect cover crop biomass. All right, and so to actually assess how effectively each tool really killed the cover crop, we look at something called cover crop bounce back. So we'll say cover crop bounced back if we return 1 to 5 weeks after we plant and terminate the cover crop, and rye had been laying down and just shot right back up and continued growing vertically. So in this case, we're really only comparing our roller treatments since there's total kill in our plowed treatment and our mowed treatment. So here we're looking at the Rhoda roller crimper compared to the Dawn roller. And we see in general that, well, overall, we had better kill in 2020 and 2021 than we did in 2019. And when comparing the rollers, the Dawn roller was more effective in terminating the rye than the roller crimper. We had less bounce back with that treatment. All right, so let's jump into the results from 2019. So again, we're splitting our results up by treatment and by the rye planting date. In addition, on this graph, we split by color the weed location because we're looking at weed biomass. So blue indicates weeds that are in the row, like in the soybean row, and gray represents weeds that we found between the rows, so in that 30-inch space between our soybean rows. And so in general, we see lower weed pressure in our plowed treatment than any of our no-till treatments. And most of those weeds are in the row where cultivators can't get at the weeds and can't remove them from the field. And so we see higher soybean yields in those plowed treatments and lower yields throughout all of our no-till treatments. And this again is fairly consistent with our hypothesis that weed pressure and yield really will have an impact on each other. All right, so this is a couple pictures from the 2019 soybean growing season. On the left, we have a plowed field. You see there's a great stand of soy coming up, not many weeds on the field at all. It was a great seed bed to plant into. And on the right side, we have a picture of a roller crimped plot. You can see a lot of those bounce backs, a lot of standing rye still in the field. There is soybean coming up, so emergence was okay, but there's also a lot of weeds coming up. And so in this instance, the rye cover crop mulch did not suppress the weeds in the way we were hoping. There's still a lot of weeds coming up. All right, so let's look at 2022. So already we see we have pretty much the opposite trend as we had in 2019. We have more weeds in the plow and cultivate treatment than our no-till treatments. And again, they're still pretty much all in the row though, so things that can't be taken out by cultivation. And with soybean yield, then we see lower yield in the plowed treatment than any of the no-till treatments. And I forgot to mention this, but there's a horizontal line on the yield graph that indicates our 5-year county average for soybean yield. And that incorporates both organic and conventional data. So in this case, both of our roller crimpers, the Rhoda roller crimper and the Dawn roller, really surpassed that threshold and had very successful yields for the year and lower weed biomass. All right, so here are some in-season pictures from our 2020 fields. On the left side, we have a plowed field. You'll see there's very few weeds between the rows, so our cultivators were doing their job. However, there are quite a few weeds in the row, mostly foxtails and some pigweeds. And then in the middle, we have a picture of our roller crimped plots. They're very clean, have very few weeds, so that mulch we see in the middle is very even and thick, and it's successfully suppressing the weeds both in the row and between the row. And then on the right here, we have our mow and ted treatment. And so there's very few weeds here, but Yichao and I chose to include this photo because it really highlights some of the benefits and some of the drawbacks of this system, some of the challenges we've encountered. So again, there's very few weeds, so there is a mulch there. However, it's not very evenly spread. And so in some areas, the mulch is so thick that it's actually impeding soybean emergence. This method just really won't allow us to evenly spread the mulch across plots. And so while there may be reduced weed pressure, we also are seeing some reduced yield just because of a lower stand count. All right, so by harvest time, the fields looked a little different. So on the left, we have plow and cultivate. Those in-row weeds really had become so large and obstructive that we can't even really see the soybeans in the plot anymore. And on the roller crimper side, we definitely have a few weeds like all organic plots do, but not to the extent that it's impeding our ability to harvest or to get a good stand out of the soybeans. All right, so finally we got to 2021, which is the final year of our experiment on this farm. And so weed pressure varied pretty widely between treatments, as well as soybean yields. Again, we did see that the roller crimper treated plots had higher yields and surpassed that 5-year Berks County average, along with one of our mow and ted treatments, which we hadn't seen in the past. So there's high variability this year and high variability in the mow and ted treatment in general. All right, so we've gone through the results from each year and observed a pretty large amount of interannual variability. So what stands out when we put it all together, especially concerning weed biomass, yield, and the relationship between the two? So on this bottom left corner, we see a scatter plot that really shows a pretty direct relationship between weed pressure and yield. And so again, consistent with our hypothesis, we found that soybean yield is negatively impacted by weed pressure. And we also see that the September planted rye, so that earlier planted rye that's terminated with the Rhoda roller crimper, really demonstrated the best performance, especially in weed suppression, and also in yield. It performed consistently well compared to the other no-till treatments and performed better or similar to the plow treatment overall. All right, so there's a few trends that really stuck out to us throughout this entire experiment. Overall. So if in general, if we have low rye biomass, we tend to have higher weed pressure and lower soybean yields. And conversely, if we have high rye biomass, we tend to have lower weed pressure and higher soybean yields. This really solidifies the idea that the success of an organic no-till cash crop really depends heavily on the success of its cover crop. So finally, here at Rodale, we like to talk a lot about soil health, water quality, environmental impacts of different management practices, but we also know that for a management practice to be sustainable and to be viable, it also must be profitable. So the bottom line is the bottom line, so we can look at the economic picture. So in this graph, we kind of compiled all of the total input costs needed for each of our treatments. Because it was a controlled experiment, pretty much everything remained the same across treatments except our labor and our farm operation costs. So labor and farm operation costs were both higher in our plow and cultivate system just because of the number of passes we had to make throughout the season. We had to plow, disc, pack, then plant, and then go through a number of times to cultivate. While in especially the rolled treatments, it was just one time. We rolled the cover crop down and planted simultaneously. So that was one pass through the field to finish all of our planting. In addition, equipment-wise, we had to use multiple pieces of equipment in the plowed system, including those plows and packers and discs, and as well as all of our different cultivators. So those costs really increased. So we compared our total costs to our yield averages from the 3 years to come up with our mean annual net profit. And so the differences here are fairly clear. The September planted rye, again, that was terminated with the Rhoda roller crimper is the most profitable. It's only a 3-year experiment, but the results are fairly clear. In terms of profitability, this is the system that we would recommend. All right, and now I'll hand it back to Yichao to talk a bit about the in-season soil health findings that we found.
Well, thanks, Annie. So one of the goals of the project here is to look at how these different systems affect soil health, in-season soil health, because these are short-term experiments, not long-term, 10 years project. So we looked at how these different practices affect in-season soil health, including soil nutrient availability and labor soil carbon in that season, in a peak season. So we first looked at soil nitrate content. So nitrate, we know that's the available nitrogen in the soil that's readily available, that can be taken up by crops easily, right? So we found that in both years, when we have data in 2019, 2020, we found that the plow and cultivate, the organic tilled system had higher soil nitrate content than all these no-till systems. So that means by doing no-till, we do have reduced short-term nutrient availability, because as I mentioned that when you till, when you disc and pack, when you plow, you incorporate your cover crop residues, but also you expose the previously protected soil organic matter to microbial decomposition. So the decomposition will release soil nutrients that can be available to the crops, but also can be lost easily into the environment. We know that the nutrient, especially the nitrate, is very mobile in the soil. So if they are not taken up by the crops, they can be lost into the groundwater, right? So here we do see a reduced soil nutrient availability under the no-till compared to the tilled organic system. We also looked at soil microbial respiration, which is an indicator of the microbial activity in the soil. It's measured by a short-term incubation and measured how much carbon that's released by the microbe in the soil. We found that in general, there's no significant differences across these different treatments, but we can see that the no-till treatment, especially the roller crimper and dawn roller treatment, they tend to have a little bit higher microbial activity, microbial respiration compared to the plow and cultivate treatment. But again, these differences are not significant different, but at least they show that compared to the till system, the organic no-till system do not tend to reduce the microbial activity in the soil, right? So they probably can offer some insights into how the organic no-till systems in maintaining nutrient availability. Although you do see declines in soil nitrate content, but also the microbial activity can be a little bit higher. That may have helped maintain or improve the yield compared to the till system. So with that, we'd like to come up with several conclusions. So soybean yield, we can see, is really largely affected by weed pressure. We can see very clear negative relationship between soybean yield and weed pressure. So this is not something new. A lot of research have found that that's because soybean is short. So if they cannot canopy in a timely manner and shade the weeds, so they can be really affected by the weed pressure. And also we see the large interannual variabilities, which might be attributed to the weather condition of different years. In 2019, we had a really wet winter, really wet spring. So that may have contributed to the less than ideal cover crop biomass in that year, which caused some challenges for weed control later in the season for the organic no-till system. So weather condition is a big challenge for managing weeds for organic soybean farmers. So we need to look at the weather closely. And to compare the three organic no-till systems, we continue to see that the Rhoda roller crimper manufactured by INJ Manufacturing, plus the September planted rye, the early planting date of rye, is the most consistent system in terms of productivity and weed control and profitability. The dawn roller, which has a modified version of a hydraulic control system, always shows better kill of the cover crops in all these 3 years. But the system does not have consistent weed control compared to the Rhoda roller crimper. The reason, we don't know why. We will keep looking into that to see if for some further fine tuning can help us better use this tool. And the mow and tag treatment, although may be the most accessible system to many organic farmers, it does not deliver consistent outcome in terms of soybean germination, stem count, and weed control. So it does not give us the consistent results of soybean yield. With that, I think there's a need for us to keep working on it, to keep developing and refining technologies to offer more chemical-free weed control options. For example, in the future, what we can do is to integrate more tools into these systems. If we happen to have less than ideal cover crop biomass, then there are weeds getting out of the between the soybean rows, we can use the high residue cultivator, which is shown on the left hand side of the screen. The high residue cultivator is a tool that can cultivate underneath the high residue condition. So just cut underneath, maybe less than 1 inch of the soil to cut the roots of the weeds, but still keep all the high residue cover crops in place. And we can also use tools like the weed zapper. We can try that. Now we've been trying that for 2 years at Rhoda Institute. It works very well in controlling grasses such as ragweeds. Doesn't work very well for foxtails. So we need to find the best way to use that and maybe the best timing of using that. And also, if for our till systems, if organic soybean farmers still prefer the organic till system, plow, disc and pack, and cultivation to control weeds. If there are weeds show up in the soybean rows, we can use tools like the weed puller to pull the weeds out. So these can be added to the toolboxes of organic farmers. So with that, we would like to acknowledge the generous funding from USDA NRCS and our collaborators from UW-Madison and Iowa State University, and our Rhoda research and farm operations team, especially a lot of hard work by our research technicians and interns, also our industrial partners, Doing Equipment and I&J Manufacturing. And with that, I'd like to wrap up and welcome any questions. Okay, let's see. Okay, now we have some questions coming through in the Q&A. So the first question, what caused there to be less bounce back of the cover crops in 2021 than in 2019 and 2020? So we're seeing less bounce back of cover crops in 2021 than in 2020, right? Let's go and find that cover crop bounce back here.
Yeah.
Right. Yeah, Annie, do you want to talk a little bit about that?
Sure. So yeah, we saw a little bit fewer, a little bit lower rates of bounce back in 2021. I think that was caused by just rolling a little bit later. Our farm director here really thinks that usually we've been waiting until the cover crops reach their reproductive stage to roll. That way, when they hit the ground, they won't still be trying to exhibit vertical growth. They're like moved on to a different stage. So we rolled a little bit later this year as per his recommendation, and that's why I think we see a little bit lower bounce back results there. Still figuring it out.
Yeah, thanks. So the next question comes from Beth. Beth asked, how was the crop previous to the rye terminated? And what was the plant date of the soybeans, and what maturity group beans were planted? And it would be great to see multiple year crop rotation economics would make it more real world. Yeah, I completely agree. So at Rhoda, our standard organic cash crop rotation system is a 4-year system, which has corn, oats, soybean, and wheat. So before soybean, we would have oats. Oats, we know, are planted in March, then harvest in July in Pennsylvania. So after the harvest of oats in July, then we have a big window to plant cereal rye cover crops before September. So again, our standard cash grain rotation system is corn, oats, soybean, wheat, 4-year rotation. So by having oats and wheat in a rotation, and we can harvest them early. So we have window to plant cereal rye and hairy veg cover crops separate respectively before soybean and corn. What was the planting date of the soybean, Annie?
I don't remember exactly. It was either very late May, very early June.
Yeah.
So we always.
Yeah, I would say first half of June, depending on weather. Right. And what maturity group of beans were planted?
I don't know that off the top of my head. That's a very good question.
Yeah,
though.
me neither. I don't have an answer. It would be great to see multiple year crop rotation economics. Okay, so this is a good question. So at Rodale, our flagship research program is called the Farming Systems Trial, which I just briefly introduced. It's a 41-year-old ongoing research program comparing one conventional and 2 organic systems. And we have 2 organic systems, one legume-based organic system, 4-year rotation. And we have a manure-based organic system, which has a 9-year rotation, including a 3-year hay phase. So yeah, we are monitoring soil health. We also have conducted an economic analysis of the 3 systems divided into till and no-till. And the results have been published beginning of this year. If you Google, if you send us an email, we can share that copy of that paper with you. And here is a question from Christine. Would the weed puller work for weeds like the dog bun and that has rhizomes?
Yeah, I think that's a good question too. I think in this case, because we are using no-till as a rotation, it's like rotational no-till, not full no-till. We don't tend to have weeds like that in these fields because they are tilled occasionally. So that's not really an issue that we've had. I know though in the farming systems trial, we really only have issues with weeds like dogbane in our no-till conventional plots. That's where we've seen a lot of like, because dogbane doesn't really respond well to many of the typical herbicides people use. And so we've actually had to change our conventional herbicide regime to get at things like dogbane. But again, yeah, that's only been an issue in our conventional plots because they're totally no-till. Otherwise, yeah, we don't really have issues with like rhizome weeds in the organic systems.
Great, thanks. So the next question comes from Katie. Katie asked which aspects of this research are transferable beyond corn, soybean corn to other crops and or other regions. I'm in the arid Southwest and I'm thinking about flood irrigated specialty crops and alfalfa, as well as dryland wheat. That's a good question. Yeah, regenerative agriculture needs to be regionally and locally adapted, right? So regenerative agriculture system might look very different here from the Southwest, right? Because we have different climate, we have different soils, but I think in general, the principle should be the same, in which we would try to have diversified crop rotation that's adapted for that region. We want to encourage more organic fertilizer rather than the chemical fertilizers to help with soil biology. We want to reduce soil disturbance. So these principles, I think they should be applied in different regions. So the reason we conduct this research is we know that corn and soybean, they are the two largest commodity crops in the United States. They occupy large regions in the Midwest and in the Mid-Atlantic area. So our research, I think, mostly are have some implication for these regions. And for the Southwest region, I think maybe you can look into our research from the California Organic Center. In the beginning of the presentation, I mentioned that we have regional resource centers located in different places of this country. We have a California Organic Center. In there, we have some research for the area regions. Okay, so the next question is from Carolyn. Carolyn asked, do you have any specific recommendations on no-till options for vegetable growers, especially those that produce canneries where residue causes issues during harvest? Annie, you have experience with organic vegetable system trial, right?
A bit of experience, yeah. Yes, if you're familiar, Rhoda also has a vegetable systems trial, which is also long-term. It only started in 2017, I believe.
2016.
2016. Okay, so we don't have like 40 years of data like we do with the farming systems trial, but they are publishing. That's a very good question. I think in the vegetable systems trial, our like no-till or our no-till and full-till differences are more using like black plastic and then using a cover crop and rolling it like we are in this experiment. So I don't think they actually have like a low residue treatment. I'm not sure how you do that, unless like if you're trying to avoid black plastic and trying to avoid residue on the ground. I'm not sure how you'd achieve that without just like continuous cultivation. But that's a very good question. And Dr. Gladys Zanotti, who runs the vegetable systems trial, if you want to reach out to her, she'd probably have a lot more specific feedback than we do.
Okay. All right. It doesn't look like we have any other questions. All right. Okay. I think I hope everyone enjoyed our presentation, our webinar today. If you have any other questions, please reach out. We have our email address here. Please feel free to reach out to ask and discuss any other questions. All right. So we want to thank you again for your attention and wish you a good day and good rest of the week.
Yeah, thank you so much. Yeah, your questions are fantastic as well.
Yeah, thank you. Bye.